Okay, so this is lecture number 1, the official lecture, first lecture of the course. And I'll probably get out early tonight, who knows. But I should have my clock out. Here is my trusty clock, so I know what time it is. I'll get you out in about an hour or less. So, overview of Java. And then Wednesday what we'll end up doing is we'll start in with programming. So because a lot of people don't actually have Java installed. So what you probably want to do between now and Wednesday is install it. And as I was mentioning before, you can use a Mac, you can use a PC, you can use anything you want. Can't really do Java programming on a tablet computer, however. You still need a notebook computer for that. I haven't seen any real. Actually, there is. I shouldn't say that. There is a compiler. There's a Java compiler for the for Android tablets. So, but you probably want to use a computer. So what is Java? If you just crawled out from under a rock, well, it was developed by Sun. Not owned by Sun anymore. Owned by Oracle. So when you go out to go download it, let me show you what you need to download. Actually, take a look. Quick deviation out here. We'll go and I'll show you how to download and install it. If you're brand new to Java, don't even know what I'm talking about in terms of downloading and installing it, there's a couple of videos I put out there, and I'll show you the video links in a few minutes. How to download, walk you through step by step, how to download it, how to install it, how to set your environment variables. Because what ends up happening is people get stuck in the installation because it's not quite as straightforward as you probably think it should be at this point. But if you go here, download Java, and you go Java, you're going to be taken to this site. This site is not necessarily what you want. It's not. You're not downloading and installing the JRE, which is called the Java Runtime environment. We need the actual compiler. We need the JDK. So you got a lot of better luck if you go like this and go JDK. So if you download Java JDK, you're going to end up going to the right site. Because what ends up happening is, like, you go to a website and it says you don't have Java installed. And you click on the link. That's the site I just went to a few minutes ago. That's the one that will have you install the runtime support, the plug-in for the browser. We need more than that. So if you have that installed on your computer, then you probably don't have the JDK installed. If you have a MacBook, you already have Java installed. Comes with it right out of the box. So you don't have to worry about that. If you don't have a MacBook, and I see most of you don't have a MacBook, you'll have to install it. And the installation is the installation is not that bad. I'll just briefly summarize it for you so you know what you're expecting. But do allocate maybe an hour and maybe 2 hours, because the download takes some time and then the configuration takes some time. And I do have a Windows partition on this computer, and so I can demo stuff in Windows, but it doesn't really matter. The interface we're going to use is going to be the same. So what do you need? You're going to need to download and install Java. You want the SE downloads. So if you type in JDK, this is the one you want to see. The screen I showed you a few minutes ago that had a little red thing, that's the JRE for dummies who click on the link. I shouldn't say dummies. For people who don't have Java installed in their browser, that's the runtime environment. This is what you want to see. Something like this is what you want. You want this screen, make it a little bit bigger. And this is the one I say is kind of confusing. You don't want NetBeans, especially for taking the Android class. We're going to use Eclipse, and I'll show you that in a few minutes. But you don't want NetBeans. I mean, well, unless you really like NetBeans, and I shouldn't be putting down NetBeans. It was written in Java. It's nice. Only problem is I personally think it runs kind of slowly. So it doesn't run as fast as Eclipse. So you don't need the FX either, and you don't need the Java EE. You need this one right here. The one on the end, it's just a plain old Java. And if you get this 7, you're in good shape. If you have Java installed on your computer already, just leave it alone. Don't bother upgrading. Not too many differences between 6 and 7. Not too many added libraries. More trouble than it's worth. You can upgrade it if you want. Go through it. But you might already have a system that's working just fine. If it's not broken, don't fix it. That's my point. When you download it, you have choices, and you'll have to accept the agreement. The choices are, and you have to make sure you get the right Java version for the right platform, and it's very important if you have a 64-bit versus a 32-bit platform. If you download the wrong one, it's not going to install. So if you have a 64 and you download the 32 thinking, I have 64, the 32 should work. It doesn't work. Not like other applications where it does work. this one's not going to work. So make sure you get the right one. And here, as you can possibly see, we've got several different options, and the ones on the bottom are going to be for your Windows people. So you download it, you run through the install, then you'll have some configuration settings that you'll have to do. And those configuration settings can be found in terms of the control panel, going into system, changing your environment variables. Java is really funny. In order to actually get Java to work at a DOS prompt, you have to add it to the environment variables. And I'm going to show you in a few minutes here. I'll just bring it up right now. On the bhacker.com website, for those of you who have not ever installed Java and you're sitting here going, wow, that's a pretty fast explanation of how to install Java. Well, I got about 3 different videos that you can take a look at that's going to actually go at a lot slower pace. And the videos are going to be right here. Tutorial number 1, tutorial number 2, tutorial number 3. How to download, how to install, and how to configure. If you've got it downloaded and you've got it installed, which is not as hard as you might possibly imagine, then click on this one. It says configuring your system. If you go to a DOS prompt and you get bad command or file name when you type in Java C, in fact, I'll show you what you should get actually, because it's the same interface on a MacBook as it is on a Windows platform. If I go to this is a terminal window. Yours is going to be a DOS prompt. If I type in Java C, I should get something like this that comes up. Bunch of, this is how you use it. If you get bad command or file name and you've already installed it, go and look at that configuration video. It means you got to go in, change your environment variable. I would set your class path and your path correctly according to the video. Reboot your system as well. A lot of students change it and they go, it's still not working. Reboot. So the environment gets cleaned out and freshened up. And then go back to a DOS prompt and type in Java C, and you should hopefully get some, hopefully you'll get those syntax for how to run it. The other videos out here while I'm here, I will just go through the rest of it, is going to show you how to download and install Eclipse. Eclipse is a no-brainer though. And the misconception a lot of people have though is that they download Eclipse and it comes with Java. No. I would start with Java first, do Eclipse second. And let me go back out to the web browser. You can find Eclipse the same way, and let me show you a few things about that. If I type in download Eclipse, let me zoom in here so you can see what I'm talking about. Eclipse is not a compiler, it's an IDE, Integrated Development Environment. Really nice, actually. And I'll show you that in a few minutes. Works on the Mac, works on the PC, works on Linux, and it's what, if you're taking the Android class, is what we're going to be using for that. So you have Java and Android all in the same toolkit. So you only learn it once, and you're set. The only problem is which one of these Eclipse versions do I need to install? That's the issue. Not really the issue, but the decision-making process. And what ends up happening is some people already have Eclipse on their computer. If you already have Eclipse, slightly different problem, slightly different issue. Make sure you have one that supports Java. The older versions are all divided out. So they support C++, they support Java, they support PHP, they support Perl, but they don't cross-support. So you get there and you go, oh, I can't make a new Java project. What's wrong with that? And then it ends up happening is you end up having multiple versions of Eclipse installed, which is possible. So if you've used Eclipse for C++, you probably have installed this one right here, perhaps. If not, then maybe you've done this one. If you've got Java EE Developer from anyone who had taken that Java EE course I taught last term, if you have that down there, oh, you're good to go, because you get Java SE and you have the EE. When you get to the Java download site, if you see anything with EE, run far away from it. Do not download, do not install EE. EE stands for the Enterprise Edition. And unless you've got a lot of hard disk space available and absolutely nothing important on your computer, that wants to run fast, install EE. But you're going to get a database, you're going to get a bunch of background processes, you're going to get a bunch of stuff you don't need. And it's going to take up about 10, 15, 20 gigabytes, perhaps. The worst case, especially if it's got Oracle, if it's got or if, depending upon what else you've got installed on there. Memory hog takes up memory and makes your computer run slower. You need the SE version. SE stands for Standard Edition, not the EE, not the Enterprise Edition. Okay, after all said and done, this is the one you want, the one I've got my mouse over right here. It's the third one down. You could go with the classic. If you do this one, the Eclipse IDE for Java developers, you'll get the Android stuff too. You only have to do this once. And you have to do this for the Android class as well, if you're taking that class. You have to install Java, you have to install Eclipse. So you might as well kill two birds with one stone and just do this one. And then you got it all. And then plus this one has better support. This one here has manual add-ons, so if you have to add on support for this, you have to add on support for that. So you can kind of customize it. It's the classic, it's the no-brainer, it doesn't include anything. This one is for Java development. It will actually give you, and what I'm going to show you in a few minutes is what does it give you. So what does it give you? Once you install it, you get this little icon here on the bottom of the screen, if you can see it down here. It's got a little round thing. If you click on it, this will be interesting because I haven't clicked on this in a while. You get this little screen that comes up, and we'll see what kind of garbage I have in my Eclipse. Haven't cleaned it out yet. But next, well, Wednesday, I was going to say next week, Wednesday, we'll be compiling and stuff. So if you want to take the time and the energy, it's probably worth your while to get your computer configured. Because then you can bring your computer next week, and then we're going to creating Hello World and a bunch of other stuff with it. And then you don't have to do very much out of class if you do it in class. So let's see what we got up here. This is the main Eclipse window. And if I go File, your menus will look a little bit different because you're going to be on a Windows system probably. But if I go File, New, this is what I'm talking about. I have the support for Android installed. I'll do that in the Android class. But for this class, you'll see if you install the Java developer version, you'll get Java Project, which is what you want. And Java Project will configure everything for you automatically and set the template for everything. And you don't have to think as much. If you don't want to use Eclipse, you don't have to for this class. You can use a text editor. If you use a text editor, Notepad on a Windows machine, or Text Wrangler, or any text editor on a MacBook actually kind of works just fine as well. And then you can use the command prompt to type in Java C and compile your programs. Eclipse is the no-brainer, easier, GUI Windows version of the compiler. You know, it's IDE, so you don't have to use Notepad. Essentially, it's a little bit easier. And you have project here. You can run it, you can compile it. It's all menu driven, and as we go through the course, this is what I'm going to be using. If you like NetBeans and you want to use NetBeans, go ahead and use NetBeans. There's no requirement for any IDE of any particular nature. What you're going to be giving me is the .java files, which are text-based. So it doesn't really matter if it doesn't. It's going to be compiled on anything. It'll compile on a Windows. It'll compile on a MacBook, and it doesn't really matter because it's a text file. It's just readable text. So you're not going to be giving me class files, so don't have to worry about that either. And Java's cross-platform compatible. You don't actually have to worry about the version of Java either, but you do want to get one of the last year or so. If your Java release is extremely old, you're not going to have some of the current class support that we're going to use when we start looking at data structures for stacks and queues and stuff later on in the course, actually 4 or 5 weeks from now. When we start looking at some of the libraries, you're going to notice, oh, that's not included. I have to upgrade. But if you get something within the last year or so, like maybe SDK 6, version 6, 5 or 6 would probably work out just fine. So don't worry about it if your version's old. This here doesn't really matter if you got Helios, if you got Indigo. Any of them actually kind of work just fine as well. So if you have it, don't upgrade it unless you want to. So, questions about the software you need for the course? No? Okay, back to the lecture. Didn't get that far. Glad I took the little deviation though. So There we go. Oh, I didn't show you, but you probably noticed that it came from an Oracle site, so it's no longer owned by Sun, but that's where it actually originally came from. It's now owned by Oracle, because Oracle owns Sun. General purpose object-oriented language, yeah. Based on C++, actually a lot of the syntax is the same as C and C++. And throughout the course, for those people who do know C or C++, I'll compare some of the differences for you, and then you can probably, you know, kind of grasp some of the things. I mean, as an example, Java has built-in garbage collection, so there's no destructor. In fact, there's no pointers in Java either, so if your first class was in C and you struggled with it and you didn't like it, you'll love Java. All the bad stuff about C is gone completely. So no pointers, no alloc, dealloc, which if you're taking the Objective-C course, you're going to hate that stuff. So Java is the better of the two languages, in my opinion. So I shouldn't say you're going to hate it. It's just going to remind you. Objective-C reminds me of it is C. Well, it's C++ with a slightly separate syntax to it. And the syntax is not intuitive, not like Java. So designed for easy internet web applications. A lot of the web development is done in it. Widespread acceptance, yes. Simple, is it simple? Yes. Fixes some clumsiness features of C++. As I was mentioning before, there's no destructor. There's no copy constructor either. There's just a constructor. And if you don't know what a constructor is, don't worry about it. I'll be going through that probably as soon as Wednesday. So no pointers, automatic garbage collection. There's garbage collection, memory management. Think of it more along the lines of cleaning up stuff. So if you put something in memory, you don't have to worry about taking it out. Java does it for you. It is fully rich. There's a predefined library of everything. In fact, Swing, AWT, is just a library. It's a package that you're including. And it's knowing what features are in the package. And then you're going to make instances of objects, and it's 100% object-oriented versus C++, not really 100%. Doesn't support it as fully as Objective-C. If I were to take a look at that line, I'd say C++, yeah, kind of Objective-C, very object-oriented, and Objective-C is just like Java. So it's you can't program in a non-object-oriented fashion. So you can in C++. So the focus is on data or objects, methods of manipulating the data, all the functions associated with objects. In fact, these are kind of like what the class is based upon as well. Almost all data are objects, strings, but everything is an object in Java. Potentially better code organization and reuse, they say. Java is an interpreted language, not a compiled one, which is really the biggest difference between. Actually, Objective-C is also a compiled language, not an interpreted one. You're wondering, and also this kind of leads into lecture number 1, which I'm going to talk a little bit ahead on, but it's written on the slide here, so it merits a full explanation, I think, at this point. The first, when I typed in download Java, when I went to that website, it had a big red thing on it. Say, hey, download Java. I said, oh, that's for the no-brainers, for the website support. Then I called it the JRE, Java Runtime Environment. That's actually an operating system. In fact, you install that on your computer. Anyone who hasn't crawled out from under a rock has done this already. You should have done this. You can't surf the internet without Java these days. So you installed it at one point into your browser. And what you put in there was the runtime environment. Runtime environment is the interpreter. The interpreter is what's running your program. So you compiled it, right? Well, did you compile it? It's pre-compiled bytecode that lacks runtime support. It's binary code, but it's not like the old days when we had programs that you just double-clicked on it and they ran, like in C or C++ programs. Java requires the runtime support. So what you end up having is installing Runtime Engine, which is why you get that nasty error message on websites that say, hey, there's no Java support. So then you install it, right? So because it's interpreted, a lot of the programming features are kind of mixed. So no longer do you have to worry about stuff like memory allocation and deallocation, because the interpreter can take care of that stuff. And now you can focus more on the lines of the object-oriented and the application development component. Because what you're doing when you're programming with it is more focused on the development of the application, not necessarily the running of it on a computer. The computer part of it's already taken away for you. The interpreter is going to do it for you. So what we end up with is Java compiled generated bytecode, not native machine code, which makes it cross-platform compatible. So the same program that you write in this class, you can take and run on an Android phone. You can take and run it on a BlackBerry phone, actually. You can take and run it on a Mac computer. You can take and run it on a Windows computer. Works on anything that a Java JVM is built for. So as long as the particular device, in fact, you can run it on an iPhone. You can run Java on an iPhone if you install the support for it. If you install the JVM, you run the application on it. And it's the same code. And it's the JVM, the interpreter, that's running the program for you. Which makes Java a really nice multi-purpose language, which has given it a lot of support, especially for the internet. Because everybody connects to the internet. Who knows what you have? I mean, not everybody's using the same computer. So as long as you have a JVM that's running on your computer that's connected to the internet, you're set. You're compatible. So that's one of the main selling points, one of the reasons why Java is very popular, actually. So Java code is translated on the fly into machine-readable code instructions by the JVM. Java Virtual Machine is what's controlling it. It is portable. Same application runs on all these different platforms as I mentioned before. The sizes of primitive data types are always the same. Actually, the typing is kind of interesting. Not as many type variations in Java as you get in other languages. And it's almost impossible actually to write a device driver in Java as well. Not made for that purpose. It's made for application development. Not necessarily driver development, only because you don't have the same support for the same range of values, same memory, access to memory tools, and things of that nature. So, libraries are defined portable interfaces. It is reliable. Security. We have security policies and stuff. We'll see the security features of Java if you're taking the Android class. In this particular class, we'll look at security in terms of client-server programming. And there's certain things you can do with applications that you can't do with applets. One of the biggest things, most people discover when they start out with this is that you can't write an applet that opens a file, reads it right to a file. Well, you can't do it on the Android phone either, actually. And it's not an applet, it's an application that's running. But you set a security policy. And there's GUI tools that do that for you these days. So it's just a matter of opening up and clicking on some stuff, and then you're setting a policy. And then the policy allows you to break the rules. But there's rules. So there's things you can do, things you can't do. Why does he do that? Well, because then it cuts down the amount of misuse of the language, which makes it reliable or makes it secure. Because if the language has those features built into it, then you can potentially protect, your application can protect computers, and we don't have to worry about transporting and using code that's malicious or something of that nature. But again, you can turn those features off. You can configure it any way you want. You can write a virus in Java. There's no restriction with that. So, I mean, we call the language reliable, call it secure, but it's only as secure and reliable as the application that's built in it, if you think about it. So, let's see, I can kind of skip through that. Multi-threaded, yes, actually it is multi-threaded. We can have multiple concurrent threads, and we'll talk about thread programming actually in both classes. We'll talk about it in the Android class too. An interesting thing is that Android applications actually are Java applications that only run in one thread. Only one thread at a time runs on that platform. However, in other platforms, like computers, we can have multiple threads running simultaneously. And we can create multi-threaded applications, all organized and synchronized by the JVM. So we don't have as much deadlock issues with threads that don't stop or threads that are runaway, uncontrollable. Because we have that built-in JVM support for threading and synchronization. If you don't like thread programming, you don't have to worry about it. It's not as bad as C or C++. In fact, it's automatic. Your program automatically runs in a thread. So what you have to do is put the word synchronize on a method, and all of a sudden you've done multi-threaded synchronization. You don't have to worry about forking processes and all that other stuff that you would do in a C++ environment. Dynamic. Everything does run at runtime, and nothing happens ahead of time. Everything is dynamically allocated. Memory is dynamically allocated. It adapts to the environment, because that's how we get cross-platform compatibility. We have one program and we write for one computer, runs on all the other computers. How much memory do we have on every one of these devices? I don't know that, but the JVM does. So the JVM can actually automatically organize that stuff for you. Libraries can freely be added. Yes, in fact, it's a little easier to add packages and libraries in Java than it is in C++. And both of them are actually fairly easy in terms of library support. Interfaces promote flexibility, reusability. Okay, a bunch of different features. Java disadvantages. Well, some say that it's slower. Actually, believe it or not, the earlier versions were a bit slower running. Because you only have that JVM you load. Think about it, you're putting an operating system on top of an operating system, and you're running a program that has to be interpreted. So if you already pre-compiled it, pre-interpreted it, added in the runtime support already, it's going to run faster. Less to do when the program actually starts, as in a C or C++ environment where it's already, it's already running. Which is why some people think that the iPhone actually is faster, and actually it is. However, only because it's not interpreted, it's not running Java. So, right now though, there's really not that much of a comparison. As Java has become better and better and better and more efficient, it is relatively as fast. So, from 1999, version 3 and version 4 ran slower than C++. Version 6, 7, about the same speed, which is what we're up to at this point. This was the article here. If you're interested in it, you can go out and take a look at it. So install Java 2. You want to make sure you get, in fact, this is just going to be the code. It's the second generation. On your machine, you can install it on different platforms, as mentioned before. Follow the online instructions. Once you have it installed, you can run through this little example, and this is lecture number 1 for those people who came in late. You can create a source file, and this is what I'm going to get into next, actually, but I'm going to talk about a little bit about it right now. If you don't have Eclipse installed, you can actually do this with a text editor. Open up Notepad. The interesting thing about Java is that the file name is important. The file name actually has to match what's inside of the file. So if you put an object in the file, and I'll talk about objects in a few minutes, and the object's called Hello World App, you actually have to call the file Hello World App. If you mislabel the file, it's not going to compile. It's going to give you some interesting error message that comes out of that that says, not compilable. And you actually have to put the .java extension on there, which is kind of interesting. So you can cut and paste this if you want. It is case sensitive as well. So you cut and paste this, put it into a text file. This is your test after you have installed. And this is going to take you, as I was mentioning before, it's going to take about an hour or so. Install, configure, just open up Notepad, save this file in a directory anywhere you want. And I'm going to talk about the file in a few, but to compile it, if you're going to use a command line compiler, you're going to type in Java C space and then the name of the file. And then to run it, you just type in Java space, the name of the file. And if you get this error message here, this is the one I was saying means that you have to go back and configure your system. So this is Java C is not recognized as an internal or external command, yada yada. That usually means that it's not installed correctly. Because here's what ends up happening, and 9 times out of 10, if this is the first time you've ever installed Java, this is going to happen to you. You download it, you run through this very nice GUI, it shows you how to install everything, right? It's all done. Hey, successful, okay. And there's no evidence of anything ever being installed on your computer. You can't even see it. There's no menu item. Nothing gets put in the menu. There's nothing. It looks like nothing. And then you go, I thought I installed it. Where is it? There's no program. So the only way you know is when you try it out. And if this doesn't work, Eclipse isn't going to work either, which is the terrible part, because you'd think, well, maybe Eclipse should fix this. Nope. Eclipse is running Java C. Eclipse is running Java from the command line prompt. So if you have problems with it, check out the video. The video actually goes through all the different scenarios of everything that could go wrong with it. So if you see one of those, you have 2 choices. You can actually use from the SDK, from the download, from the bin directory, change the directory to where this file is located and run it manually. Or you can fix your environment variables by setting your path environment correctly. So to run the program, what you're going to end up doing is you're going to run the code that says Java space Hello World App. And another thing just to keep in mind is that you may or may not already have the JRE, which is the Java Runtime environment, on your computer. You could possibly just have browser support for it. It depends on what you've installed previously. When you install the JDK, or SE version, it's going to ask you, would you like to install the JRE? Go ahead and install it. Even if you think you have it on there already, go ahead and install it, because it'll just update it for you and it will match the version of the JDK. So when you write a program and you run it on the same computer, it's going to be compatible. You're not going to get strange Java error messages. Sometimes for those people who are like, oh, I don't want to install that, I already have that on there. Unselect that, unselect that. And then you should go to run it and go, oh, well, it doesn't work. No, it's not the program that has the problem. It's the JRE, is an older version of it. It doesn't support the library you just used or something that's newer or something. You don't need to install any databases for this class. Some of the downloads will have an option that says database. We're not doing any database programming in this course, so you don't have to worry about that. So if you see this, it means you need to configure your system, essentially. So I'm going to talk a little bit about the basic language features. And this is where some of you are going to be extremely bored, because we're going to start out with Programming 101 as a basic concept. But before I start, I'm kind of curious, how many people have had C before? C programmers, so you have to raise your hand. This is the audience participation part. Raise your hand if you've taken a C course before. Okay, so raise your hand if you've never taken a programming course before. Okay, so I have to start at the bare basics, don't I? Yeah. All right, so this first week, actually the rest of today and Wednesday is going to be extremely boring for you guys who already have taken a programming course before. Because I'm going to maybe take this first week and just go over basic stuff, like what's a variable, what's a line of code. And then unfortunately I'm going to have to go through the hello world thing on Wednesday. So if this is your very first programming course, bring a computer with you if you can. And I'll make sure we have more power supplies so you can plug stuff in. Because it'll be very beneficial for you to get your compiler working, get it compiling, get it running. Then you have more confidence. Especially if you're brand new to Java, it's not a bad idea. Even if you have programming experience in other languages, until you actually compiled your first program, you have no idea what you're doing. So, to do it here, then take a break, and I can fix your problems for you. Fix the syntax error so you can get it installed. So it's a lot easier to learn it when you have some help with it. Actually, you can't look at a PowerPoint slide and learn how to program. That doesn't work. So. Unfortunately, however, I have to use PowerPoint in order to give you basic concepts. So here's basic concept number one. And this is where experienced people are going to be bored, but humor me for a few. Variables, data. So what do we do in a Java program when we do the same thing? So this stuff applies to any programming language. We have two activities that occur in a program. We have data storage, and we have processing of the data. So data and processing. Processing are your control functions. What are control functions? Iteration, looping, paths through the program, routes. I'll talk about that in a lot more detail in a few minutes. The flip side of that is, how do we keep values? So data comes in a couple different forms. Every programming language uses this concept of the variable. And what's a variable? It's a single piece of data storage, and it comes in different types. For most people in this class, you'll have to worry about 2 or 3 different types. String type, and a string is just nothing more than characters. So we have a character, in fact here it is here, this CHAR character here, is just one character. A, B, C, D, just one single character. String is multiple characters. In fact, I don't see, here's a string here. String down here. Multiple different characters. Integer, you don't have to worry about that. In fact, it's int, it's up here. Integer, you'll use integers. Floats, you'll probably use a float. What's a float? It's a double. Well, what's a double? It's an integer. Well, you know what an integer is from math, I hope. It's a single integral value 1, 0, 1, 2, 3, 4. Doubles and floats are partial values, so we have 1.5, 1.6, 60. Doubles are 2, so we have 1. Dot dot or XX, so we have 1.50 would be a double. 1.5 would be less than a double. 1.505 would be 3 past the decimal. So 2 past the decimal place is a double. Most people use floats because then you can get 3, 4, 5, so you can get a bigger range. So what is all the differences between all of these different variable data types? Well, it's the range of values that it supports and the operations that you can do on it. Most people aren't going to use shorts and longs. Shorts and longs are shorter versions of integers. So an integer is just a number. Some programming languages actually just say number. Number. In fact, you'll see this with Objective-C. It's just number, string, not number. Makes it a little easier. Experience programming, Boolean is a true or false, an on or an off. Some languages support it with a 0 and a 1. Some languages have the word true, the word false. So the language support gives it different characteristics in terms of how it's used in the language. These are called primitives. Java supports 8 primitive types. These are the 8 types. Primitive means they're built in. They're the lowest form. A primitive is the native. It's the original definition of something. Then we have non-primitives, and what are those? Those are implemented by the programmer, or they're implemented by the language, and those would be class types in Java. So everything non-primitive in Java is a class. What's a class? It's the implementation of an object. What's an object? Everything. So believe it or not, a string, an array, object, a frame, a person, an animal are all programmer defined non-primitive values that are objects that are implemented in the form of a class. So starting Wednesday, I'm not going to make a class tonight, but starting Wednesday we will see class this, class that, class, everything we're creating is a class. If you've taken C or C++, you know there's a structure, there's a union, there's a type defines, enumerations, a bunch of, nothing like that in Java. Just a class. We just take and create classes in Java. So it's a little simpler in terms of the abstraction, but the functionality is the same. A class type, either provided by Java or made by the programmer, exists. Why reinvent the wheel when we can use an array and we can have a built-in object or a string as an example, or even the integer, which is a form of an object. It's both a primitive and an object actually, but it can be used in both ways depending upon whether you're making an instance of the object, I'll talk about that in a few, or if you're just using it as a piece of data that you're going to essentially use in a program. So this is the boring part, back to the data, the variables. So we follow, in fact this is a standard format you're going to see in practically every language. When you declare variables, so we have declaration, we have initialization, and then we have usage. So Java, just like regular old imperative languages that go line by line, and here's the other interesting difference between Java, actually, because I just mentioned imperative languages. If an imperative language, also commonly called a structured language, also called line-by-line procedural language, starts at the top of the program and runs to the bottom of the program, and you go line by line. It's like BASIC. Anyone heard of that language, you know, from years ago? C actually runs the same way, but C is actually a little different because you have functions in there too. Java doesn't run this way. So we don't write programs by starting at the top of the listing, and there's no line numbers or anything like that. All we do is make classes, and then we have this class, that class, and that class, and we put them all in different files, and then we have one class that's called a driver class, and that makes instances of all the other classes. So we have this thing called a class, and a class, you know, this is the textbook definition, is the template for an object. It's the code that creates the object. Objects don't exist until they're instantiated. So we have another word, instance or instantiation, which means when we make an instance of an object, we're using a concept called instantiation, which is kind of like birth. The object is born, and then the object lives, and the object throughout its life does stuff. And the object has both data and processing associated with it. And so the programming methodology, and this is basic object orientation in terms of the overall concept, is to create a bunch of classes and then create another program that makes instances of those classes and makes the classes interact with each other. And it interacts through methods or messages that get sent back and forth between the objects. And we can make many different driver programs and use the same objects over and over again, which is why they call Java reusable. It has reusable components. So what you should be doing as a developer, Java developer, is creating a repository or a library of classes. So let's say, for example, I created a student class. A student class represented the real-world object of the student. And I made an instance of that object in one program. And then later on I say, I need another student. So I make another instance of the same student object. I have this in this library, in this package that I've created. And I'll talk about packages and libraries and stuff like that next Wednesday. But I just keep making instances of this student object over and over again. And then eventually I decide, well, I need a graduate student object. So I inherit a graduate student object from the existing student object. And I build multiple functionality on the concepts. That's what you're doing, and that's the programming methodology. You're making objects, creating driver programs that are using these objects, inheriting objects from objects, and that's pretty much object orientation. So it's a little different than traditional style, but it does follow traditional style syntax, which is why I mentioned this to begin with. And one of them is the variable concept. And variables, as I mentioned before, hold data. The data is kept inside of the object. So the object is going to have variables, and they usually call them data members. And then we have these member functions. The member functions are the behaviors or the methods that are associated with this particular object. But the core concept is those data members. What's a data member? Well, it's a variable that's going to hold a piece of information about the object. So if I talk about student objects again, everyone in here has a student ID, whether you actually know it or not. You have a name. You might have a birth date or something. You might have, I don't know, driver's license numbers. You have all this information. Well, we have to store those in data members or variables. And the variables, we give it a type depending upon the type of information we're storing. So if it's a name, it's probably going to be a string. A string is multiple characters together. So we would use down here, and this is kind of like where I'm pointing my mouse right now. Actually, I can make it a little bit bigger. Now it's super big. Here's some examples of what's called a variable declaration and an initialization. And this is the old concept used in many different languages. But in order to define a variable, we have to give it a data type. In this particular case, we're calling it an integer because we're going to store, let's say, the number 5 as an example. Maybe this is going to be age. We have these young baby objects, and their ages 1 through 5. We want to keep track of them by their age. So we could use int. Here is the data type, and the syntax just follows like this. It's the data type, a space, the name of the variable. Java actually, just like any other language, has different naming conventions. As an example, every language allows you to store just one character for the name. Some of them, actually Java as well as C++, requires that the first character actually be a character and not a special character like an underscore or something. You can't have spaces in names. There's a bunch of rules associated with the naming. And I'm not going to bore you with that. Instead, you can read that in a book probably. Or actually, probably have some examples coming up, but I'm not going to go that low. But here we have a Boolean b equals to true, and then we have a semicolon at the end of each line. So, and I'll review all of this syntax next week when we start writing Hello World. Or next week. Wednesday. I have to get this into my head. We meet twice a week. Wednesday, when we start writing programs, I'll go over the syntax, but every single line is going to have a semicolon at the end. You're going to have to figure out how to, you can declare multiple variables all in the same line. You can initialize them together. And there's actually 2 steps to it. And you'll get this in any programming language. The declaration is technically just saying integer x. The initialization is giving x a value. So this would be the initialization right here, x is equal to 5. After we've said integer x, we've already defined x. And we can say, well, x is just in existence and it's of type integer. So then we can say x is equal to 5. So these can be different lines. In fact, you can write the entire program all on one line if you want, because each one of your statements is separated by a semicolon. So you don't have to worry about that, but it's kind of hard to read it. So normally you'd see this on 2 separate lines, actually. These are all the same. These are all examples of the same thing using different variable types. I'm not going to talk about arrays tonight. I'll have a separate lecture on arrays. But an array is multiple variables of any type, but they're all the same type. So if we have an array of strings, an array of integers, an array of floats, it just means we have more than one, and we have to define how many we want. Do we want 10 of them, 15 of them? So basically, here's an example here where we're saying integer array. This is the name of the variable. This is the data type. We use these brackets to show more than one, because in the brackets we're going to put a number. This one's going to be, new int. I'm not going to go with the new yet, but so this will be the value of 2. And I'll have a separate lecture on arrays, but this is just basically saying item number 1, which is array index 0, is equal to 12, and then we initialize them by using the number where they fit into the index for how many of them we have, and which one of those 5 or 6 do we want to assign a value to. And we can use syntax here. In fact, this is string x, which is how are you. We have using quotation marks to say it's a string. So the syntax of how you write the statement for the initialization and also for the declaration is going to be specific towards the type of variable that you're declaring. But in essence, that's the concept. And as I was mentioning before, we have 2 components. We have data, and then we have processing. And processing, which is really referred to as flow control, or flow of control. That's where we get our if, or if-else, or where, or while, or switches, or cases. If you know C or C++, it's all the same. It's the same functionality all over again. If you don't, Wednesday, I'm going to be going through all this with a lot more detail. What is flow control? It's the program path. It basically determines when a user presses on something or does something, something is going to happen, and that's the control or the processing. So we have data, we have processing. Objects keep them both together. The flow control is going to be in our methods and our functionality. I mean, what can we do with X? We can store a value. So we can't really do anything past storing values with variables. But we can have a switch statement or a for or a while to do iteration, which is looping, stuff like that, to basically have some functionality exist. So you might think the flow of control is the functionality, the options, and we are working with an event-driven environment, actually, but we don't have to. It could be user control. So event-driven, just to define that concept, is when the user clicks on something and the user does something and the program responds to that event that occurs. Or we have predetermined events that the user does not decide on. And that would be something in which the program did something. It printed something out, it did something in the background, maybe not in response to what the user initiated, who knows. So here's some more sources. This is all comes, in fact, these are links. If you download the lecture I just clicked on here to show you, it should bring up the link. And the link is going to be from the Oracle site, and this is from the SE site, so it's getting started. If you don't go through and get the DDL and DDL text that I recommended, you can use these links. Each one of the lectures has links in there for Java tutorials and stuff. I will warn you ahead of time, though, all of the Sun documentation, well, Oracle documentation now, which was originally written by Sun, very big, very lengthy, very detailed. It's not like the shortened version of it like you get in most books, textbooks. It doesn't read like a textbook. It's more like a manual. So not the best reading, but in some cases it does do the trick. So all right. So that was lecture number 1, and I'm actually going to go press ahead now to lecture number 2. talk about object orientation. Probably not going to get through the whole thing. But I'm not going to keep you too long tonight because I know some of you, this is the first night of class. Why are you going to keep us? We're not going to go till 7:30, however. We're going to normally go, well, actually this is about normal time. Another 10 minutes, actually. We'll go from 5 to 6:30 is what we'll do. And we'll do that twice a week. And then we have, if you're in the next class, we'll have a little break. And then at 6:30-ish, 6:45, we'll start the second class. But not tonight. We have to wait till 7:30 tonight. Because that's what it was published in the schedule as. So. Or I could wait and do this one next. You know what? I'll give you a break. Now I'm feeling guilty. I'll give you a break. I used to hate it when I used to classes on the first night. I didn't have anything installed. Didn't have, I was just here, taking notes. I don't even have the book yet. Don't even know what's going on. And the teacher would just go on and on and on, lecture forever. So I'm not going to do that to you. Come back Wednesday. Bring a computer. Have Java installed on it. Or better yet, install Java. If you have a problem with it, bring your computer. I'll allocate some time on Wednesday to troubleshoot environment variables and settings. So at least you have a working development system. And I'll make sure I have more power supplies for you to plug stuff in. And then we're going to start writing programs on Wednesday. So in the meantime, get your system configured and show up Wednesday. And the class will start at 5, actually. And it'll run from 5 to 6:30. And everyone who came in late, did you sign the roster? Well, let me end this video so we don't have to waste time. I'm sorry?
This is the first time